Hi everyone, I'm Tim Kington and this is Coding is for the Birds. One of the things I wanted to try on this channel is building some larger projects. When you're learning to code, a lot of times you're learning things in class or working on online tutorials, and they're very small programs. Even when you work on something over several chapters of a book or for a few weeks in a course, the final product winds up being, 5 classes, a few hundred lines of code. It's really just not a life-size project. So I thought it might be interesting to work through some larger projects. In a book or an online tutorial, the solution is usually simple enough that you kind of just write the right code. Maybe you write parts of it over several chapters, but you're just adding code on and you're not really changing the design. The code doesn't really evolve. It's more just being aggregated, right? You're adding pieces until the code is finished. In a larger project, that's not how things work. You start out writing some code and things are simple, and as you try to add more features, things get more complicated, and you have to figure out how to handle that complexity in your design. So you need to refactor the code, you need to add classes, you might need to use some design patterns. So I think it'll be really instructive to work on a large project and see that in action. For the first project, I thought I would try to build a simple version of the Java virtual machine. It's going to be a very stripped down version. The real Java virtual machine is very large and complicated, but I think we can get a version without too much trouble that will run some very simple Java code. And then we can keep adding on to it and see how far we get. This is an interesting project also because we will learn a lot about how Java works along the way. The first thing I wanted to do here is be able to read in a class file and dump out some of the information inside it. Here we have the Java virtual machine spec. Chapter 4 is all about the class file format. And here is the definition of the file. So we have these are unsigned 4-byte integers, unsigned 2-byte integers. So we have 4 bytes, that is the magic number that identifies a class file. We have some 2-byte integers for the minor and major version. Then we have the number of things in the constant pool, and then there's an array of these CP info structures, which define the constants. Then we have a bunch of other 2-byte integers. We've got an array of interface IDs. We have some info on fields and methods and attributes. So I wanted to write some code that will load a class file, go through and basically just dump all of this information to the screen. So let's start with that. I went ahead and created a couple of projects here. This plain Java app will be the program where we're going to write some very simple code and then look at the class files that are generated. And then there's a MyVM app that is going to be the virtual machine. So let's start by making this as simple as we possibly can. We'll just say x equals 1. Get that compiled. We have a tool called JavaP that can dump a class file. So this can tell us if we're on the right track. And this gives us sort of a text representation of what's in the file. So this is a very simple little application. We've got a constructor for the app class here. We've got our main method, and it's really doing very little. But this is a start. We can also take a look at what's in the class file using this hex dump plugin that I have for VS Code. So this is a very small class file. You can see there are some constant strings defined in here that are referencing some methods and classes and things. But the actual code is probably going to be, the last couple of lines here. There's going to be very little actual code. So let's try to go through this file and parse things out. I guess we'll want a class here for that. We'll make it load a file in the constructor. So we should be able to use a data input stream for this. And this is going to throw IO exceptions. And then we'll do a close, I guess. I don't really care about exceptions, right? This is kind of a toy program, so we're not going to worry about error handling. So now we need to read our file. I copied this. So let's go through and read these fields. So most of these we're going to throw away for now. So we'll say read u4, and we'll give it a string so that we can print this out as we go. So u4 fits into an int. And so we'll read that and we'll print it out. And I guess this data input stream needs to be a member of the class, or we're going to have to pass it all over the place. And then I'm going to want to print the name and the value. Is there an integer.toString I think I can use that will do it in hex? Hex would be kind of nice. Some of these will be weird negative numbers otherwise. And then here we're going to return our value. This is going to throw an exception. Keep wanting to say throw there. Okay, what's wrong with this? Yeah, that's just de-important. Okay. So we can read that and it'll print it. And this is really enough to get started. So let's create a parser and make that work. So this is going to be what, app.class. We're going to have to figure out what directory we're in here. So I guess maybe we should do this with a file. That'll probably tell me. Alright, so now, okay, so we're in the plain Java folder, so we just need to go into bin, I think. Okay, we got our magic. It didn't print correctly. I guess 2 hex string might be what we want. Okay, now it's working. All right, so that problem was that the toString with the radix handles negative numbers funny. But if we do 2 hex string, now we get Cafe Babe, which is the magic number that we're supposed to see. So now we can read a bunch of these other fields. So let's do minor version. Major version and constant pull count. We need a read u2 function. I guess this will return a short. Probably doesn't matter. We could probably just use an int here. Is there a short 2 hex string? There's not. So I guess it doesn't really matter. We're going to convert the short to an int and print it as a hex string, and that should all be fine. So, okay, so minor version is 0, major version is 3C, which is 60. That seems about right. And then our constant pull count is 19. That seems a little high for a program with nothing in it. But I believe the constant pull is used to reference class names and method names and a lot of other stuff. So that might be reasonable. Now, the next thing is an array of CP info structures. So we're going to have to find that. All right, so CP info looks like this. We're going to need to store this. And this is weird. It's constant pull count -1 here. So we need to actually subtract 1. They made this 1 higher than the number of things in the constant pool. And then we're going to read this many constants, I guess. So for consts, let's say read const info. For now, we won't store it anywhere. We're just going to try to read it. This is what our const info looks like. So we'll say read u1 tag. And then we're going to read the info. This is an array of u1. So that must depend on our tag, I guess. We're going to need to read u1. It's going to return a byte. Byte here. So we could run this right now, but it would print the wrong stuff because it would read a bunch of bytes in a row. We need to figure out what this info thing is. Okay, so we have a bunch of different tags here. And then depending on that, we're going to have to look at the section and figure out what to do. So right now, we're probably not going to need all of these. So let's just run the code and look at what the first tag is, and then we'll try to handle that type. I keep hitting run on the wrong file here. I need to, at some point, I should set up my launch.json. All right, so we read our versions and constant pool count. Our first tag is 7. Which is a class. That's probably going to be one of the harder ones. Okay, so let's try to handle that. So we're going to need some constants. And so in here, we'll have a switch for these. All right. And now let's figure out what class is. This has a tag inside it as well. No, this is a repeat of the tag that we saw before. This is a 7. Then we have a u2, which is name index. Oh, that's not so bad. Okay. So when we see this, we'll say read const class. And this just needs to read a u2, which will be, we'll call it const class name index. Okay, that should get us a little further. All right, so we got 19, our tag was 7, our name index was 2, then our tag was 1, and that's another constant type that we haven't seen before. 1 is constant UTF-8, and that looks like this. Okay, we need another constant here. Now we need to read this. We've already read the tag, so let's read the length. And then we're going to have to read the bytes for the string. So this probably should return a string. Let's see how that goes. So we got tag 1, length 3, bytes. The string is app, so that's good. Const class name index 700. How did that happen? Ah, yes, we need a break here. Okay, so we got our string. Actually, we're getting a bunch of strings now. That's cool. App. We got Java object. Init. I guess I'd like to get rid of these const UTF-8 prints, right? Sometimes we want to dump these things as we read them, and sometimes we don't. So maybe we should add a flag to say if we want to or not. Actually, we could probably, what if I did this? Okay. Yeah, that's sort of a tricky way of having an optional parameter in Java. This is var arg, so I can pass any number of booleans, and log is an array of the booleans that were passed in. So if we call this with only the name and no booleans, then the length of the array will be 0. So here for tag, I do want to log it, and down here I don't. This will make our output a little cleaner. Okay, so we got our const UTF-8. We're getting app. We got another class. We got a string Java object. We got init. We got this parenthesis v thing, something called code. And then we hit a constant type 10 that we're going to have to handle next. This is a method ref. Let's see what that looks like. These are all the same. Maybe we'll create a member ref or something. Anyway, we're not going to save the data for now, so we'll just read this. 10 was the number, right? It's not a string. So we'll read our class index. And our name and type index. And I guess that's it for our method ref. This was 10. Maybe this should be called const method ref. All right, so we did get a method ref here. Class index 3, type and name index 9. And then our next one is a 12. We're slowly making progress through the file here. 12 is a name and type. So we'll read our name index. That was weird. What happened? This was number C, so 12. I don't know why it always wants to indent switch statements incorrectly in VS Code, but it really doesn't like the way I want to indent them. I did something wrong here. What did I do? I broke it. Yes, I accidentally deleted the one that we had here. Hey, we got through all the constants. Cool. So we're getting these class name indexes, some more strings, and we've reached the end of the constant pool. That's great. So what's next? Now we have a bunch of U2s. So we should have access flags. This class, superclass, interfaces count. And then we have an array of interfaces. We probably don't have any of these. Let's just go ahead and run this and see if we get any. All right, that's 0. So we don't have to worry about what these interface objects look like. How about fields? No fields. Methods, we probably have methods. We've got to have a couple of methods, right? We have a constructor Yeah, we have a constructor and a main method, so we are going to have to do something about our methods. So what are these? I'm starting to think this should be indented to match up with the code. Let's see if we have any attributes or not. No, I forgot to put my, no. Yeah, I forgot to put the code that's going to actually read the methods, right? So we had an attribute. We do have attributes on both of them, so we're going to have to handle that. I guess attributes can be very long. It can be more than 65K, 64K. We probably need to read these into a byte array or something at some point, so I might as well do that here. We don't need a name. You know what would have been more clever here is probably to just pass null when we don't want to log something. Let's fix that. This is where I did want to log. Let's find the other calls. All right, so that's read the attribute. I'm curious if these are readable strings or not. So let's go ahead and try this. They are definitely not. All right, so For now, we're not going to do anything with that data. So we got method attribute count 2, and then we read the index, the length, and presumably the data for those. We're getting close to the end here. Now we've got to check attributes here at the end, attribute count. We do have an attribute to read. So I think the other attribute bit that we were doing, no, these attributes are the same thing. Okay, so we already know how to read these. Okay, so we should have made it to the end of the file there. Now we need to figure out what to do with this data. Okay, so we managed to get all the way through the class file. We haven't done anything interesting with the pieces or worried about how they fit together yet. So that's what we'll tackle next. Don't forget to like and subscribe.